Is this your
Little buddy.
Remember the guy on the junior chip who was like, princess?
I have chickens.
And he was like, you can pet her very nicely. Princess very nice. She's very precious.
Is it actually the 16th?
Billy Will and Justice.
I don't know. Is it?
Because to be honest, this entire week I've been running on date.
Every day feels like Friday.
Even
Feels like
if
Friday.
They definitely felt like Friday, yeah.
She keeps writing the date smaller and smaller.
Who?
Sam isn't gonna be here.
They
Why?
will
Why
tell.
Sam
It's
gone?
not me, I think. No, he's going to Cocoa Beach.
Yeah.
Yes. Where's
For
that?
what though?
So soon.
Swim.
He always comes back and
He was very pumped about it.
Very dark.
Does that mean I want to keep Buzz's head this night. He was in Buzz with the night before. Remember that one day he came back for a picture day and like buzzed?
Okay.
Sam was.
What's this in degrees right here up top? 90.
70.
And then radians. Pi over 2, because this is pi, so that's half. Pi plus pi over 2 would equal 3 pi over 2. 2 pi. Alright, so on number 1, we're supposed to draw 7 pi over 3. Probably the best way to think about it is change it to a mixed number. How do we change 7/3 into a mixed number? Do 7 divided by 3, which is what? 2 with the remainder of 1. So it'd be like 2 1/3 pi. So this is 2 pi right here after a full revolution. So 1/3 pi would be in like 1/3 of the way to here. So it's 2 pi's all the way around and 1/3 is 1/3 of the way to about right there. So it looks like that. That's the answer to number 1. You just have to draw it with including the
Circle thing.
curly, yeah. Because you have to show it goes around more than once. Alright. Number 3, where would negative 370 be?
10 below. 10 below 360.
Yeah, because negative 360. 360 is right here, right? So 370 would just be a little bit farther. But you're going in clockwise direction. With negative degrees. Negative. Okay, number 5. How do we find a reference angle? Well, probably should first figure out what quadrant it's in. Because remember, basically reference angles are how far is it from 0 or 360 or 2 pi, whatever we're doing, or how far is it from 180 or pi. That's the reference angle. So what quadrant is 4 pi over 3 in? Negative 4 pi over 3. Well, 3 over 3 pi would just be pi. So negative 4/3 would be right there. You don't have to draw it on this one, but. So how far is, this is pi, this is also negative pi. How far is 4/3 pi from pi? So you could just do,
1/3.
yeah, it is 1/3 pi. Or they probably put pi over 3. What'd you say?
33%
Yeah, 33%. Pi over 3. Uh, 11 pi over 12, that's almost 12/12 pi, so that's almost pi. So reference angles are never negative, so I would do like 1 pi minus 11/12 pi. If you subtract it backwards, it would make it negative or you could do 12 twelfths minus 1 twelfth. 11 twelfths is 1 twelfth. So it's pi over 12, 1 12th pi, or pi over 12. What birthday you guys think it is? Happy birthday and so. Sophomores. One classic. Play you devil. Whose birthday is it? Adeline. Happy birthday.
Angie.
She works there?
Okay. Number 9, it's kind of the opposite of like number 1, or the first page. Well, here's maybe the best way to do it is if you go like a rotation and a half, how many radians is that? You guys know? If it did make it all the way around. So this is how many radians? Just from here to here. 1 pi, 2 pi, 3 pi. But if you look at the picture, they didn't quite make it to 3 pi. They're a little bit short. So you do 3 pi minus pi over 6. It's kind of a mess. You guys remember how to change fractions? Just multiply by 6 on top and bottom. You could use your calculator. I don't care about it. So it's 18 minus 1 pi is 17 pi over 6. I don't like teaching 6th grade math to 11th graders. Or any grade really, for that matter. Okay, number 11. Adding and subtracting fractions. That part. You guys forget it and I don't like reteaching it. Number 11. You're not forgiven. 11 is kind of similar. It goes around a loop and a half plus a little bit more. So it goes around 3 pi plus an extra pi over 3. So it's kind of like the last one. If I multiply by 3, I need 9 pi over 3. Should equal 10 pi over 3. 9 pi plus 1 pi is 10 pi. Okay, convert to radians. Do you guys remember the radian converter?
180 over pi?
It is 180 over pi, yes. Some of them are degrees to radians, some of them are radians to degrees. So, for degrees, it's the other way around, it's pi over 180. Because you want to like cancel out the degrees part and multiply in the pi part. If you don't have a nice calculator, I think like Sam didn't have a good one for pi, you just plug in negative 240 times 1 over 80, 1 over 180, and your calculator should turn that into a fraction, like 4/3. So, and then you throw the pi in there, it'd be negative 4 pi over 3. So, this is the converter from degrees to radians. Divide out the degrees, multiply in the radians. On 15, you could use times pi, 180 over pi. Because it's the other way around. But do you guys remember the easier way to do 15? Guess no. So pi is just worth how many degrees? How many degrees?
Oh, 180.
180. So you can just do 8 times 180. Just throw 180 in there. And that would get it.
480.
You could also multiply by this, the whole thing by 180 over pi. Divide out the radians, multiply them. Okay, 17. $630 times pi over 180. These are both divisible by 90. So that would be 7 and 2. 7 pi over 2. Do. I don't know. I don't know if I want to talk about the back page very much. What should, I gotta get my throat. A lovely singing voice. Might need to get some water. 20, for example, though, what should we plug in the calculator? If it's secant,
1 over cosine of 30.
yeah, secant is 1 over cosine. You do need to put it in the calculator, though. But yeah, you can plug that in. Oh, that's not 19. That's not 19, that was 20. We're just jumping around a little bit. 23 is cosecant, so what should we plug in for that one? 1 over sine. It does say negative 90.
How many decimal points?
Darn it. Which one are you getting a decimal on?
20.
I thought the calculator might.
Square root.
I didn't give a decimal.
Mhm.
Mine's in radians.
Okay. Yeah. I was hoping the calculator could handle it. These are supposed to come out kind of nice, quote unquote, like with square roots and fractions. Alright, anyways, I'll leave you guys to it.